couple of components that you might see on a circuit board. Okay, so I think I didn't share the screen. So the first picture shows capacitors, the second one are resistors. Yeah, so at least 4 electrical components that you can find inside a computer circuit board. So we can find resistors, capacitors, diodes, then transistors, right? And switches, inductors. Right? Those are simple things. And then it comes with like integrated circuits. Right. You can list a whole bunch of this. Okay, so if you can submit it, it's okay. I will check the settings, but you don't need to redo it. I'll give you the credit for participation today. Okay, it's not letting me submit the last question I have. Yeah, so okay, don't worry. Troubleshooting will take the whole hour, so I'm not going to troubleshoot that, and I'm not mark you down for that. Oh,
thank you.
Yeah, sometimes things are not working as we wish. All right, so these are the announcement I made in the beginning of the class. But if you were late, it's here. So we will have the first exam on next week Thursday. So you need to do that exam between 9:30 a.m. and 10:45 a.m. on Thursday. That's the class time. So I think you are available. Then there will be a mock exam open on Canvas or TopHat. I will send you an announcement on Canvas saying like how to find it. And it is not for graded, it is not a graded assignment, but it is for you to practice. And the second homework will be open tomorrow, like I did last week. And in the exam, I'll cover all the topics that we learned until today. Okay. All right, so if you have any other questions, you may wait after the class and then we can talk about the issue. All right. Okay, so let's continue on this topic. So remember that you are on a recorded meeting here. So if you wish not to show your picture, you may cover it. I try to crop all those out from the video. So I was able to do that for the first lecture that I recorded, but not for the second one. I'm working on it because here and there I see your faces. I'm trying to crop it out, but I'll do it. If you wish not to show your picture, you may cover your video. It's up to you. Sometimes when you speak up or if the sounds playing on your side, your screen pop up. So just let you know. So I'm recording the meeting. If you wish not to show your picture, you may cover it. Right. So let's continue on the lecture. So the plan for today to finish this topic and do a couple of questions on TopHat and finish this material. So everything that cover up to today will be tested in the exam. All right. So the other day, this is where we stopped. So we talked about the Ohm's law. This is a very useful law in electricity. That is talk about the relationship between the current, voltage, and resistance across a component, like especially across the resistance, resistor. So the electrical current flowing through a given portion of an electric circuit is directly proportional. Proportional means current is, when the current increases, the other component increases, or when the other component increases, the current increases. So current is proportional to the voltage difference. So I is proportional to the voltage difference and inversely proportional to the resistance. Anyway, you can edit or rearrange this equation to show like V equal IR. So that's the Ohm's law, delta V equal IR. This delta stands for the difference. So the voltage difference between these two sides of the resistor is equal to the current going through the circuit times the resistors. Okay, and the resistance measured in ohms. So the units to measure resistance is ohm, and the symbol is this Greek letter ohm. Okay, basically 1 ohm means voltage per amp, volts per amp, because it's Here resistance, if you rearrange this equation, it will be delta V divided by current. So voltage measured in volts, and then the current measured in amps. So volt per amp is resistance. Okay. Right. Now let's try this problem here. So if we know the resistance of a given portion of a circuit and the applied voltage, then we should be able to calculate the current go through the circuit. Right? So here's an example. So we have a 1.5 volt battery and it's connected to a 20 ohm resistance of a light bulb. So we can use the Ohm's law here. So current is equal to voltage divided by resistance. Right? So here current is equal to voltage divided by the resistance. So here in this circuit, the voltage across the bulb is 1.5 volts and we divide it by the resistance, which is 20 ohms. So 1.5 volts divided by 20 ohm, that's 0.075 amps or 75 milliamps. So amp, if you multiply this by 10 to the power 3, it's milliamps. So 1 ampere is 1000 milliamps. Here, so if you are given with the voltage and resistance, then you can calculate current. If we have the current and the resistance, then we can calculate voltage. If we know the voltage and current, then we can calculate the resistance. So we can use the Ohm's law equation, this equation, to calculate any unknown component if we know the other two. Okay, so this is an example. So we are not going beyond these calculations, like advanced calculation than this. So you should be able to calculate a voltage, current, or resistance on a simple circuit like this. Okay. All right. So the electromotive force, EMF. So in some electrical circuits or in textbooks, we don't mention about the voltage, but we hear the word electromotive force. It sounds like a force, right? Electromotive. So it is the voltage. So electromotive force is same as the voltage. So voltage is the value, that's energy involved in the battery. So it is produced by the chemical reaction happening inside the battery. So, you know, like battery is a real component. So there's a resistance involved in there as well. So when we're talking about the circuits, these wires are not like identical. They does have some resistance in there. Right? Similarly, inside the battery, there's some resistance. So basically, about 1.5 volt battery, we can see about 5 ohm resistance inside. So the increase in the potential energy per unit charge provided by the chemical reaction in the battery is called the electromotive force. So it's this electromotive force, or that potential energy, is coming from the chemical reaction that happens inside the battery. So here, I'm sorry. So the total resistance in the circuit will be the resistance of the battery and the resistance of the bulb. If we consider these wires to be identical, I mean, ideal situation, like there's no resistance in the wires. So these are physics wires, let's say. So no resistance, those are physics wires, not real wires. Real wires does have resistance in there. So the total resistance in this circuit will be the resistance of the battery plus the resistance of the bulb. All right, so these circuits, we can simply make circuits into, let's say, patterns. So one is series connection and the other one is parallel connection. So here, this is a simple circuit where we see a battery, a switch, and a bulb. So, you know, when we close the switch, this bulb should lead, right? It should light up. So so in a series circuit, there are no junctions. There are no points in the circuit where the circuit can branch into second loop. So if you think about this circuit, there's only one loop here. So this is a series connection. So the switch, the bulb, and the battery is in a series connection. So there's only one loop, single loop here. It is a series connection. So the current that goes through the circuit will go flow around the loop in the same amount. So if the battery is producing 5 amp current, everywhere you should be able to see 5 amp in the circuit, because there's no junction that it can divide into branches. All right, now look at this circuit. Are those bulbs in series with the battery? Yeah, so the first thing you need to check is whether there's only one loop or not. So there's only one loop, right? So any current that's coming out from the battery should go through the first resistor, second resistor, and the third resistor and come back to the battery. So there's only one single loop in the circuit. So these bulbs are in series connection with the battery. Now this symbol is to represent the resistor. So bulb is a resistor in the circuit. Okay, so the total resistance in the system will be the addition of each resistor. So the total resistance in this circuit will be R1 plus R2 plus R3. What is R1, R2, and R3? Those are the resistance of each bulb. So the units for R1, R2, and R3 is ohms. Okay, so what happened to the current when it's go through the first bulb? So let's say this is the first bulb. So whatever the current come through here from the battery will flow through the first bulb, and then it will flow through the second one and the third one. So do you think some current will get used up? It will not happen, even though you see the light bulb lights up and you see the light energy, but the current that go through the circuit will be same everywhere on the circuit. So if you measure the current over here, and if you measure the current over here, here, or here, it will be the same value. So the same current passed through each component. It's very similar to the classical example of water flow in a pipe. So if there's just one loop of pipes that's connected to the water pump, then the water should go like whatever the amount that went out from the pump should come back to the pump. There's no way that we are using the current in there like a water. So in the circuit, there's no use of current, but it's will be continuously flow through there. So we call this as the conservation of charges. Okay, now what about the voltage? So voltage decreases by the Ohm's law, you know, like delta V equal IR. So each component keep that voltage across the two sides of the component. So for example, this bulb will have a voltage across it, and this one has its own voltage across it and a voltage across the third one. So the current is the same, but voltage will be changed depending on the resistance. If we have the same resistance, then the voltage will be the same. Anyway, this circuit is behave like a voltage divider. So the total voltage that's supplied by the battery will get divided into each resistor. Okay, so for example, if this provide a 9 volt, then the voltage across the first bulb plus the voltage across the second bulb and the voltage across the third bulb will adds up to the voltage of the battery. In a second, I will open a circuit diagram and let's measure it. Right? Okay, so this is the second type of the circuit pattern. So that is the parallel circuit. So as you see here, here's 3 bulbs connected in parallel to this the battery. So basically, you see more than one loop that current can flow through. So see, like the first, as you see here in this schematic diagram, so this is the first loop. That's the current can go through the first bulb. Then this is the second one, that current can go through the second bulb. And here's the third one. So there are 3 loops in this circuit. Actually more than 3 loops, because you can see another one here, another one here, right? But if you think about the loops that connected to the battery, there are 3 loops that connected to the battery. So basically when the current comes into this junction, it can get divided. So this parallel circuit behave like a current divider. Current can be divided into branches here. So the total current that's entered to this junction will divide it into two pieces. And whatever the current that comes to this junction, again, will divide it into two pieces. So this is a current divider. It's very similar to this analogy with the classical way of looking at it by the water pump. So here, nozzle, there are three nozzles that put the water out. So there are three branches. Very similarly here, there are three branches. So the battery current provided by the battery will get divided into three pieces. But the voltage will stay the same across each component. So see, like both side of the bulb is connected directly to the battery, right? So if you cover this up, there's another loop here connected to the battery. And if you cover up these first two branches, then the third one also connected to the two sides of the battery. So the voltage across each component is same as the voltage of the battery. Now, here, this is how we can calculate the total resistance of the circuit, because these components are connected parallel. So the 1 over R parallel, I mean 1 over the total resistance of the circuit, is equal to 1 over R1 plus 1 over R2 plus 1 over R3. If you remember, in the series circuit, it's R1 plus R2 plus R3, right? Now here it is different. It's 1 over R total is equal to 1 over R1 plus 1 over R2 plus 1 over R3. All right, now here's the comparison of two circuits. So in the first one, it's so the first diagram here is a connection of series, connection of resistors. So the total resistance is addition of three resistors. If there are more than three, you keep adding. And here's the second diagram with the parallel circuit in there. So the total resistance can be calculated using this equation. So if you do this calculation like here, in the first one, you add the total, each resistors to get the total resistance. So this will increase the total resistance in the circuit. But on this one, because it's 1 over, so you reduce the total resistance value in the circuit. So what is the benefit of that? So when we have less resistance in a circuit, then we can keep the battery running for a while than having the resistors in series, because here high resistance, so we need a big power to continuously run the voltage, I mean the current through the circuit. Okay, so let's try this one. Okay, so think about this. So look at the circuit. So this is a possible question in the exam. So you will see a couple of questions like this. So here it's asking how much current passed through each light bulb. Now, first thing you have to do is you need to look at the diagram. So here you see the real component in the picture, and here's the schematic of the circuit diagram. So here, as you see, two bulbs are connected. Is it in series or is it in parallel? How can we find it out? So as I see here, there are two loops that's connected to the battery. So it can be, right? So these are in parallel to each other. Now it's asking how much current passed through each light bulb. Now, nice thing about this problem is the resistance are equal to each other, 10 ohm and 10 ohm, right? Now, let's forget about the second loop. Let's think about the first loop here. So the battery is 6 volt and it's connected to a 10 ohm resistor. Okay, let's forget about the component over here. Can you do that? No, we can't. We can't. So we cannot forget about each component. So we have to think about the total resistance in the circuit, right? So what is the total resistance in this circuit? Okay, I'm going to get rid of this maximized version of the PowerPoint and I'm going to work on this. Yeah, all right. So let's do this way. So if you think about the 10 ohm resistor here, the voltage across the 10 ohm resistor is 6 volts, right? So for this first resistor, it's 10 ohm and the voltage across is 6 volts because it's directly connected to the battery. Now you can calculate the current using this equation. That's Ohm's law, right? So the voltage across the resistor is 6 volts and you divide it by the resistance, it's 10 ohm. It doesn't matter which one of this is because both resistors are 10 ohm each and it's connected to a 6 volt battery. So when you do this calculation, you end up getting the value of 0.6 amps. So across, I mean, in each, if you think about the current that go through each resistor, it will be 0.6 amps. Then what is the total current that drag from the battery? This 0.6 amps goes through the first resistor and also 0.6 amps go through the 10 ohm resistor, the second one. So as this is a current divider, so the total current that comes out from the battery get divided into two pieces equally because they are equal resistors. So here 0.6 volts and here 0.6 volts. So altogether it will be 1.2 amps, 0.6 plus 0.6. So there will be 1.2 amps coming out from the battery. Okay, I'll give you a couple of seconds to think about this one. And think about what is the, like you can decide what is the answer is, then I'll go over that. So there are 3 identical resistors, each 15 ohm, and they are connected parallel with one another. Then each of these resistor is connected to a 10 volt battery. And internal resistance are negligible. That means these are physics wires and physics resistors. So, and a physics battery, let's say. So there's no internal resistance from each component. So whatever the given value is the value, that's it. But in real life, the resistance comes out from all the connected wires and the internal resistance of the battery. Also, the resistors are heating up, the resistance are changing. But this is an ideal situation. Okay? In the circuit, there's a 10 volt battery and 3 15 ohm resistors. So what is the equivalent resistance of this parallel combination? So it's asking the total resistance in the circuit.
Is it A?
Okay. Let's see.
No.
Okay, let's try it again. So this is a parallel circuit, right? So this is the equation to calculate. So 1 over R parallel is 1 over R1, 1 over R2 plus 1 over R3. All right, so let's substitute the numbers. I keep the units so I don't get messed up with the units. So here it's 1 over 15 ohm plus 1 over 15 ohm plus 1 over 15 ohms. Okay, so it will be 3 over 15 ohms. So if you simplify this, it's 1 over 5 ohms. But remember, 1 over R parallel is equal to 1 over 5 ohms. Then what is the value of R parallel? You need to flip it over, right? So you need to flip it. So it will be 5 ohms. Okay. Spend a couple of minutes thinking about it and do the calculation again. So I don't know who spoke up earlier, but you mentioned it's A. Did you? Did you calculate the current or? I'm not sure.
Yeah, I just did what we did last time.
Okay, Kylan, yes.
It's Kaylin. Sorry.
Kellen, okay.
Yeah.
I'm sorry, Kellen. Yeah, so this is how you should calculate it. Now, you might think, oh, it's 1 over 5 ohms. Actually, it's not, because 1 over 5 ohms is equal to 1 over R parallel. So you need to flip it over to get the R value. Are we good? Can I move on? Okay, I think I can, so I'll move on. All right, so this is a, let's say a simple picture of a household connection of circuits. So we have a table lamp and a toaster and also a TV. very old-fashioned TV, but this is a kind of simple equipments that we are using in the houses. So how are they connected? So is there any reason that it's connected in this fashion? So is it household circuits are connected seriously or in parallel?
Parallel.
It should be parallel. Why? Then think about, like, if we connect the things in series, then if we break the one of the circuit, then there's no current going through the other circuit. So when we lose current in the kitchen, we will lose the current in the bathroom, right? So series connection is not the best way because of that loop breakout. And also, like when the circuits are in resistors are in connected parallelly, the total resistance is a small number. So the power outage will be low. So we are not losing energy that much by having these connected in parallel to each other. It reduces the total resistance, and then it reduces the power use in the circuit. Okay, so only way that we can break out the current that come to the household is breaking the circuit somewhere here. So that's a circuit breakers. So maybe in all of your houses, there should be a circuit breaker that you can switch that off or on. Those are called the tip switch in your house. Like in each component, you have a tip switch for each bathroom or each bedroom. There's a switch that you can switch off the current or switch on.